before we hear from our speakers about the latest trends and threats to the AppSec world, I wanted to take a moment to set some context around the history for some of those threats. AppSec has decades of lists, acronyms, taxonomies, and scanners for flaws like cross-site scripting and SQL injection. And yet barely 3 months into 2025, we already have several hundred CVEs for just those two vulns alone. What does this mean for a future where LLMs produce code, attackers produce backdoored LLMs, and supply chains struggle with trust? What did AppSec miss in promoting secure designs? Why should we trust AppSec to fix new problems when so many old ones are still around? So bear with me as we take a little bit of a journey to the past. Let's start near the beginning of the web. At the end of 1994, Netscape introduced their browser, and along with it, a few custom HTML extensions. After all, HTML hadn't even been officially standardized yet. The most notorious one was the blink tag. I hope nobody here has ever had to suffer through the obnoxiousness of that blink tag. But my point is that Netscape released their browser at the end of 1994, and within a month, the blink tag was already annoying people. Let's fast forward to 2013, and Firefox, the spiritual descendant of Netscape's browser, finally removed support for that awful, awful tag. But if it took 20 years of complaining to kill off a terrible tag, what does that slow pace imply for security? Maybe security needs to swap out complaining for creating something. So bear with me. Let's go back to 1995 for a moment. So just that 1 year later, in October of that year, Netscape launched something that sounds familiar to today, a bugs bounty. Important that it was plural because who knows how many bugs there were at the time. The winner back in 1995 for a bug bounty created what's essentially a cross-site scripting attack. They just used LiveScript before it was called JavaScript. Today, we have bug bounties. Today, our browsers still have JavaScript. Today, long sigh, websites still have cross-site scripting. Like I said, we've got a few hundred CVEs for that, just 2025 alone. But just imagine, what if Kendrick Lamar had had a beef with cross-site scripting? That vuln class would have been over and done with within months. No way it would have survived all these decades. AppSec needs more of that Kendrick energy. But let's jump around in time. Let's roll forward back to 2013. This is just a few months after that blink tag disappeared, and what I think is one of the best steps towards ending cross-site scripting. This is a great moment. One of the reasons I like to highlight this is that React, this project, didn't come out of AppSec or an AppSec project or a checklist or anything like that. React came out of an engineering-focused effort. It doesn't mean it wasn't informed by AppSec, but what React did was solve a problem that was important to developers, and it did so in a way that would enable developers to build apps without having to mentally track tedious security controls that entire time. So the next time someone says developers don't care about security, ask if security knows anything about development. Like I said, we need diss tracks that are directed towards vulnerability classes, not directed towards developers. Now, part of the reason I'm jumping through all this time is that in addition to React hopefully killing off cross-site scripting, we actually saw some browser developers and AppSec teams eradicating a couple other common vulnerabilities. Later on today, we're going to hear from Robert Hansen, RSnake. He and Jeremiah Grossman popularized the clickjacking attack around 2008 or so. But clickjacking, you don't really hear about that today. It mostly disappeared because browsers and the security community got together to create more secure design choices and make available something like the X-Frame options header, make available things like CSP, although I'll have to admit CSP possibly falls in that category of great security idea, but not so great developer experience. So we'll come back to that DX in a moment. Similar to clickjacking, there was CSRF. CSRF blew up in the mid-2000s, late 2010s, but it's largely disappeared as well because browsers and the security community created the same site cookie attribute, an attribute whose default setting is more secure and critically, was largely transparent to site owners. That developer experience, once again, was mostly, here's a new attribute, it makes your life more secure, and by the way, you probably don't have to do anything new. Importantly, same site does provide ways for configuring and handling edge cases, but those were edge cases that developers discovered, knew about, and got help to handle with. So I'm highlighting these and wanted to take this step back into the past because I like pointing out that secure designs are in fact possible. Eradicating a class of flaws is in fact possible, but that possibility only becomes reality when the secure design is simpler to adopt and more naturally a part of that developer experience. We don't need AppSec teams creating checklists. We need them working with developers to create secure designs by default. For example, hardening guides should always now, today, just consider that an anti-pattern. But of course, I do have to admit, not all development has been secure. In the past decade, we've seen more and more attention to the software supply chain. It's a perennial, top of mind list for the last decade, at least for CISOs. And developers constantly have to deal with security scanners, reporting CVEs and package dependencies. It's admittedly an annoying amount of tedious, there's that word again, work that ends up being based more on listing known vulnerabilities rather than dealing with meaningful risk. Thankfully, many scanners today are learning this lesson and, like Qualys, presenting smarter scan results. But you've hung out with me in the past. 2024, in particular, had a different type of supply chain problem, one rooted in trust. Last year, we saw a very cool, from a technical perspective, in terms of the planning and its organization, consequences not so cool, but it was a well-planned attack, like I said, that introduced a backdoor into XZ utils. It was patient. That planning and setup for it spanned a few years. It wasn't something that was just, here's a random phishing link, please click on this, and voila, backdoor. We had seen this type of outcome before, in the sense of a package modified to contain malicious code, but the attack vector in those situations tended to come from the compromise of that project maintainer's account, meaning there was a weak password, a stolen password, that phishing link that I mentioned, some sort of authentication or authorization bypass. XZ was more subtle. It was based on a long con to convince the project's owner to add another trusted maintainer who could build and release official packages. And that's what makes that attack insidious. It used sock puppet attacks to ratchet up pressure on the maintainer to address a slew of feature requests and then step in to offer help. It wasn't saying, nice project you got there, be a shame if it burnt down. That was entirely too obvious. Instead, it was more like, you seem so overwhelmed. I've made a few contributions to your project. How about I help you maintain it? This was a case where the attacker was both cause and offered the cure. And what it really boiled down to was a stark demonstration of, once again, going back in time to a paper from 1985 by Ken Thompson, Reflections on Trusting Trust. The point of his paper was that it's what would happen to trust in the software ecosystem if Ken, or someone like Ken, put a backdoor into a compiler. And then that backdoor in the compiler didn't modify your source code. It just compiled a binary that just so happened to have a root login inside it. No source code modification needed. So no longer were you now able to look at your source code and think, am I secure? You actually had to find that insecure needle in that machine code haystack. Which, incidentally, this is roughly what happened to SolarWinds, that idea of an attacker using in-memory modification of the code. But the reason I bring this up is, once again, the past repeats itself. 40 years later, let's look at 2024. This is when Anthropic was writing about this very same concept of trust, only they swapped out the compiler with an LLM. And they basically said, look what we've done. We can train our model to have a backdoor that, to quote, when triggered, involves switching from writing safe code to inserting code with vulnerabilities. And then if we look at just last month, We heard a lot about DeepSeek and a researcher who presented a very, very practical example of demonstrating how to subtly adjust the weights of DeepSeek's model to create bad seek. In other words, an LLM that could introduce a backdoor into the code it generates. So there we've gone from the past of cross-site scripting to cross-site scripting we can still find today, to the past of trusting, or should we trust the people who's writing our software, to now extending that how do we trust people into how do we trust people and how do we trust LLMs creating the software that we run today. And that's why I wanted to highlight that modern AppSec is no longer about creating lists of findings. It's about turning lists of findings into evaluations of risk, and is doing so in a way that saves everybody time and gives developers concise, relevant guidance. We can have relative guidance as well. Einstein was probably right about AppSec at one point. What I'd like to wrap up here is the idea that chasing bugs and creating lists isn't a strategy. What if there was a secure design that could eradicate vuln classes? What if that design already existed, but what if nobody used it? That's where AppSec is still struggling. Today's presenters will be talking about APIs, LLMs, AppSec trends, and AppSec threats, but they'll also be sharing insights on strategies that fit into modern security. With luck, we'll start seeing more organizations turn those strategies into action. I hope yours is one of them.